Hi guys, in this video we are going to take a look at using cylindrical coordinates to compute volume of a given solid. The first thing I'm going to explain is a little bit of an introduction to cylindrical coordinates. So imagine that you have regular rectangular coordinates x, y, and z. So you have some point right here, this is point P, and x, y, z are the coordinates. How do we find cylindrical coordinates of this point? So what we do first is we're gonna make a projection of this point to the xy plane. So xy plane has equation, hopefully you already know, z equals 0, right? So this is xy plane. Every point on the xy plane has z coordinate 0. How do you find the projection? Well, this is very simple. So if you have coordinates x, y, and z of your point, so what you do is you drop a perpendicular to the xy plane, and so let's say it's going to be somewhere over here, and this point P prime will have the same x and the same y coordinates, but z coordinate is going to be 0. Okay, so that's what we do, and then it's always going to be just like polar coordinates, which hopefully you already know in 2 dimensions. So what is polar coordinates? So remember that polar coordinates will have a r, which is the distance from a point to the origin. But this time it's not the point itself, it's its projection to the xy plane. So this right here, this distance, that's going to be your r. Okay, cylindrical coordinates, and you can think of it as the same thing as in polar. So this will be your r. And then the theta is going to be the angle with the positive x-axis. Now, the z stays the same. So the coordinates of this point P are now going to be, instead of x, it's going to be r and y theta, let's just say, and z will stay the same. So it'll be r theta z. Okay, so that's the story about cylindrical coordinates. So z stays the same, z is z. But x is just like with polar, it's going to be r cosine theta, and y will be r sine theta. And then also x squared plus y squared, which you should know, which was the same thing as in polar, will be r squared. And the last thing that we should know is that when we're integrating over cylindrical coordinates, over some solid, we have to multiply by an extra r, which is called the Jacobian. So it's going to be the same as in polar. So that's the good news. Okay, so what are we trying to do here? So what we have here is the solid that bounded below by the xy plane. And then it's going to be inside the cylinder, x squared plus y squared equals 64. And above, it's going to be bounded by z equals 9. Now, I wanted to show you what that's going to look like using Calcplot 3D. First of all, when you look at an equation, x squared plus y squared equals 64, one thing that you notice is that it does not have a z. If it was just a 2-dimensional situation, then hopefully you realize that this is just a circle with radius 8. But because this is 3 dimensions, z is basically anything. So you take that circle and just move it up and down, and it becomes a cylinder. So I'm going to demonstrate. So if I were to insert an implicit surface, and under the selection, I use implicit surface, and I just type x squared plus y squared equals 64. Okay, so select that. Nothing happens because of the scale, right? So I will need to zoom out, and one more time, and maybe one more time. So now you could see that cylinder, right? So it's like a circle, and you're moving it up and down. Now, it's going to be bounded below by the xy plane. Now, what's the equation of the xy plane? That's z equals 0. So again, I'm going to insert just to make it easy, another implicit surface, and just say, okay, that would be z equals 0. Okay, and then select another one, and again, implicit surface, and just use z equal 9 for that one. Okay, so this will just be z equals 9. Okay, so you can see that the solid is going to be between those two planes, and laterally it's going to be bounded by the cylinder. So it's pretty easy to set up the cylindrical coordinates for this situation. Very easy. So let's go ahead and do that. So what are we going to do? So first of all, we got a solid. So this is x squared plus y squared equals 64 is the cylinder. And then it's between z equals 0, z equals 9. All right, so what we do to set it up, first of all, over here, these limits should be the projection to the 2xy plane. But projection of that solid between, it's like a can, basically. Think of a Coke can. Projection on the xy plane is going to be disk of radius radius 8, right? 8 because this is 64 here, so 8 squared is 64. And then over here, this would be the bottom curve to the top curve. But it's very clear from the picture that the bottom curve is z equals 0 and the top curve is z equals 9. So that's going to be your limits on z. So this will be 0 to 9. Now, because you are computing a volume, anytime it says compute the volume, you are integrating 1. So this is just going to be 1. And then we go dz. And then we'll go d rho or dr, sorry. dr d theta. Okay, so what remains is just to set up the dr d theta, but because we're integrating over the disk with a radius 8, right, it's very easy to set it up. Remember, in polar coordinates, the r is going to go from 0 to the radius, right? So this is your circle, right? Well, this is a circle or some radius 8, whatever. So we fix an angle. And we say, okay, if I fix an angle theta, how does r change? So r would go from 0 to, let's say, 8 would be the radius, right? So this is going to be the radius right there. And so that's 0, 8. Now, how about theta? Because it's a whole circle, this is just going to be 0 to 2 pi. Okay, so evaluating this integral is going to be very easy, but what I did is I just forgot something. Now remember, anytime you're switching from either rectangular coordinates to polar or rectangular coordinates in 3 dimensions to cylindrical, you have to add that extra r, which is called the Jacobian. So you're really not integrating 1, you are integrating r. Now, the good news about this is going to be super easy because this integral is splittable into 3. When can we split an integral? So look, none of the limits have any variables in them, right? So whether it's r or theta or z, there are no variables, which means that we can just split them apart into 3 single integrals. Now, there is no theta in the integrand. It only has r. So this is just going to be integrating 1. And then we'll multiply that from 0 to a, integrate r. And then multiply that from 0 to 9, integrate z. Okay, so now let's compute. Okay, so this part, that's very easy. That's just going to be 2 pi. Integrating r becomes r squared divided by 2, and we substitute 0, 8. And then integrating z from 0 to 9 is just basically subtracting 9 minus 0, which is going to be 9. So to summarize, we get 2 pi, 64 divided by 2, that's 32, and then multiply that by 9. That's going to be my answer. So I think we can just... you don't even have to simplify. You can compute the numbers on the calculator, but other than that, that's it.